Assalamu alaikum everyone. Welcome to the third video of the calculus course of Chest Academy. As I said in the previous video, in this video I will be showing problems of both integration and differentiation. But I have decided to separate integration and differentiation into two videos, or else the video would be too long. Thus, in this video we will only look through the problems of differentiation, and in the next video we will look through the problems of integration. So now let's get started. As you can see, I have written some topics of differentiation on this page. These are the several topics of differentiation you need to know. Like, differentiation consists of five topics according to our syllabus: techniques of differentiation, stationary points and nature, and tangent normal, mensuration, and rate of change and approximation. These are the five topics you need to know according to our syllabus. I'll be covering all the topics in this video by showing you various problems of all the topics. So let's not waste any more time and let's get started. So first we have techniques of differentiation. It's not a hard topic because it's just simply you'll be provided with an equation and you'll be asked to differentiate it. Let's look at a few problems. First, we have question one. We are given with an equation that is 2x plus 3 to the power 5, then again bracket x plus 2 to the power 8. We are told to differentiate this equation. So let's see how do we do it. So first we say let y is equals to the equation 2x 3 5. Now we write dy by dx to differentiate it. So let's see what the formula list says how to differentiate this equation. We can see that this equation is an UV equation. That is, we multiply two factors. In this equation, two factors that contains variables. This the x that you see are variables. So we multiply two factors containing the variables. Here, one factor is 2x plus 3 to the power 5, and the other factor is x plus 2 to the power 8. These are two factors that are multiplied, and thus this formula, thus we need to use the formula of UV differentiation. So if you look at the third formula, it says differentiating UV, d by dx UV. Here u and v means two factors that contains variables. Like in this case, this is u and this is v. So how is this differentiation done? Let's see what the formula tells us. The formula says first we take u and then multiply it with the derivative of v. Then we add the entire thing with v multiplied by the derivative of u. So let's do it. First, let's write down the formula. It's v du dx. Sorry. I wrote dv. V du dx plus u dv dx. U dv dx. So it says we need to derive u, then we need to derive v. So first let's derive u. D dx 3 to the power 5. So how do we derive this? To derive this particular equation, we have another formula. That is, if you look at the second formula, sorry. If you look at the second formula, here it shows there is a bracket and there is a variable inside the brackets, and there is a power outside the brackets. How do we derive this equation? We take the power in front, subtract 1 from the power, and then we multiply the entire thing with the derivative of the bracket. Like here, a is the power, they put a in the front, then they subtracted 1 from the power, a minus 1. Then what did they do? They differentiated whatever that's in the bracket without the power. They differentiated px plus q. So let's do it. Here we first, sorry. Here we first bring the power in front, 5. Then write the bracket 2x. Then we subtract 1 from the power, 5 minus 1. Then we multiply the entire thing with the dvdx, sorry, no, multiplied with ddx of 2x plus 3. 2x plus 3. Let's do it. 5. Let's simplify the equation. 5 3 to the power 4. And we know if we differentiate a linear equation like 2x plus 3, we subtract 1 from the power of x and bring the old power in front. The old power was 1, then we bring 1 in front, that's 1 multiplied by 2 gets 2, and subtract 1 from the power of x. The power of x was 1, so 1 minus 1 0, x to the power 0 is 1. So we write 2, and if we differentiate 3 we get a 0. So 2 plus 0. So the equation becomes 5 multiplied by 2 plus 0 is 2, as it's a multiplication, is as there is a multiplication symbol between 5 and 2, we multiply 5 times 2, which is 10. So du by dx becomes 10 bracket 2x plus 3 whole to the power 4. This is du by dx. This is du by dx. Now let's do dv by dx. ddx of v. What is v? v is plus 2. V is x plus 2 to the power 8, whole to the power 8. So let's do it. X plus 2 to the power 8. Now we're going to do the same thing. We're going to bring power in front. X plus 2, 1 minus the power, that is 8 minus. Then we multiply, then we derive this, then we differentiate this d by dx, x plus 2. Now let's simplify the equation. 8 x plus 2, 8 minus 1, 7. And if we differentiate this, it becomes 1. The power of x is 1, and so we'll bring 1 in front. 1, then subtract 1 from the power, that is x to the power 0. Then it becomes 1 plus, as 2 is, as if we differentiate a number without a variable, that becomes 0. Thus 2, if differentiation of 2 is 0. So the final equation becomes 8 times 1 x plus 2 to the power 7. So if 8 times 1 is 8, it is 8 plus 2 to the power 7. So this is dx. Now let's substitute dv by dx and du by dx in this formula to find the dy by dx. dy by dx. So what is v? First we need to put v. What is v? X plus 2 to the power 8. So let's do it. X plus 2 to the power 8. Then we put du by dx. Du by dx. So what is du by dx? This is du by dx. Let's mark this as du by dx. Du by dx, and this is dv by dx. Okay. So after putting the, as this was v, after putting v, we put du by dx. So du by dx is 10 2x plus 3 to the power 4. Then add. Then the plus sign. After the plus sign, we put u dv dx. So what is u? 2x plus 3 to the power 5. So let's put 2x plus 3. 2x plus 3 to the power 5. Then after putting u, we put dv by dx. U dv, v du dx plus u dv dx. dv by dx. So this is dv by dx. So thus we put 8 8 x plus 2 to the power 7. So now if we simplify the equation, we'll get dy by dx. Let's simplify. It becomes 10 x plus 2 to the power 8, 2x plus 3 to the power 4, plus 8, 2x plus 3 to the power 5 is a plus sign, x to the power 7. Sorry. Now I can further simplify this equation by taking common. Like we can say on the both side of the plus, that is on the right side as well as on the left side, we have x plus 2 as well as 2x plus 3. So we can take both as common. Like I can take x plus 2 to the power 7, sorry, 7 as well as 2x plus 3 to the power 4 as common. Then it becomes our second bracket. As I've taken x 2x plus 3 to the power 4 common, then it becomes 1. 2x plus 3 becomes 1. I've also taken x plus 2 to the power 7 as common, then it becomes 10 x plus 2. So x plus 2 to the power 1, not 8. As I have taken x plus 2 to the power 7 as common, thus I will subtract 8 minus 7 to put the final power. Thus it becomes x 10 x plus 2 to the power 1. Then I put the plus sign. Now as I've taken 2x plus 2 to the power 7 as common, thus it becomes 1, and 2x plus 3 to the power 4 as common, thus I subtract 4 from 5 to make it 8, 2x plus 3 to the power 1. So this is dy by dx. I can choose not to put 1s on top, as your wish, as putting 1 and not putting 1 is the same thing. Thus, this is the differentiation of 2x plus 3 to the power 5 bracket x plus 2 to the power 8. If you are confused at some point, you can watch up the video again, then move on to the next question. Now let's move on to the next question. So in the second question, we have another equation where we have been asked to differentiate this equation. Okay, so let's see how it's done. If you see in this case, we are dividing factors. That is, we have numerators and we have denominators. In the numerator, we have minus 4x squared. Then on the denominator, we have 5x minus 2. So we have variables on both in the both numerator and as well as the denominator. Thus, we have to use the formula of u by v. U, v. If you look at the formula list, there is a particular formula given for such equation. That is ddx of u by v. That first we take v, then multiply it with the differentiation of u minus u ddx v, and we divide the entire thing with v square. And this is the fourth formula. Then let's write down the formula first. Dy by dx is, in case of this u by v differentiation, we write down the formula first. That is v du dx minus u dv dx. This is v with sharp edges, and this is u with soft corners, dv dx. And then we divide the entire thing with v. So first let's find out du by dx and dv by dx. So in case of du by dx, what is u? Oh yes, always the numerator is u and the denominator is v, always. By saying v, we mean the denominator, and by saying u, we mean the numerator in case of an u by v differentiation. So first let's do du by dx. What is u? U is minus 4x squared. So ddx minus 4x squared. How do we do it? How do we do it? We bring the power in front. So we first multiply 2 minus 4x, then we subtract 1 from the power, it becomes x to the power 1. So it is minus 8x. Now in case of the dv by dx, we write ddx. What is v? 5x minus 2. 5x minus 2. So what do we do here? We bring the power of x in front. Power of x is 1. 1. If you bring 1 in front, it is 5, as 5 times 1 is 1. So we write 5. Then we subtract 1 from the power. That the initial power was 1. And if we subtract 1, it becomes 0. 1 minus 1, 0. And x to the power 0 is 1. So we don't need to write 1. 5. And if we differentiate a number without a variable, then it becomes 0. So if we differentiate minus 2, it's 0. So the dv by dx is 5. Okay. Now let's continue with the dy by dx. In dy by dx, we first need to write v. According to the formula, we first need to use v. What is v? V was 5x minus 2. So let's write 5x minus 2. Then we write du by dx. What was du by dx? Minus 8x. So let's write minus 8x. Then we subtract with the minus sign. Then we write u. What was u? Minus 4x. This is u and this is v. Minus 4x. Let's write minus 4x squared. Then we write dv by dx. What is dv by dx? It's 5. As dv by dx is 5, let's write 5. Then we divide the entire thing with v squared. What was v? V was 5x minus 2. So we divide it with 5x minus 2 whole square. Now we just have to simplify this equation to get dy by dx. Let's simplify. If you multiply minus 8x with 5x, it becomes minus 40x squared. Then if you multiply minus 8x with minus 2, it becomes plus 16x, as minus 2 minus combines to become plus. Then we subtract. If you multiply 5 with minus 4, it becomes minus 20x by 5x minus 2 whole square. Now let's again do some simplification. Minus 40x squared plus 16x. 2 minus combines to become plus 20x squared. Then again we divide the entire thing with 5x minus 2. Then afterwards, finally, we subtract, we do 16x minus 40 plus 20 becomes minus 20x square by 5x minus 2 also. So this is the dy by dx. When we, sorry, when we differentiate this equation, when we differentiate minus 4x square by 5x minus 2, we get 16x minus 20 by 5x minus 2 to the whole square. This is the dy by dx. So these two are questions of techniques of differentiation. In techniques of differentiation, we are just provided with some equations and we are asked to differentiate that equation. Nothing tough. Thus, let's go on with the next topic, that is stationary points and nature. Oh, sorry. There would be an x after 20. Forgot to put the x. There would be an x after 20. As there x squared, not x squared. As minus 40x squared plus 20x squared is x squared. When minus 20x squared, there would be an x squared, sorry. So now let's go on with the next topic, that is stationary points and its nature. So what do we actually understand by stationary points? As I said earlier in the differentiation and in the video where I taught differentiation finds the gradient of a particular point on a particular curve. So let's say we have a curve like this. So here we can say there is a turning point. Initially the curve was downward sloping, then it became upward sloping. So there is obviously a turning point where the gradient was zero. That means if a tangent was drawn at that point, it would have been a flat line or flat horizontal line with zero gradient. Thus, if we differentiate, let's say the equation of this curve is y is equals to fx. So if we differentiate this equation and substitute it to be and equate that equation to be zero, we'll find the x coordinate of the stationary point. What is a stationary point? The point where the curve has zero gradient, or the turning point. At the turning point, the gradient is zero. M. By saying m, we mean gradient. Thus, m is equals to zero at the stationary point. There are two types of stationary point. One is a maximum and one is a minimum. Let's draw another graph. In this case, there is a minimum stationary point because because after, let's say this point A is the stationary point of this curve. At point A, the curve has zero gradient. So why is this a minimum point? Because there is no y value or below point. The minimum y value that the curve can have is at A. There is no y value less than A. Thus, its minimum is the minimum point. But if you have a curve like this, and let's say the stationary point is B, then it has a maximum stationary point because there is no y value after B. At point B, the curve has its maximum y value because after that the curve does not have any y value. The curve has a y value below B, has many y values below B, but it does not have any y value after above B. Thus, it is a maximum point, maximum stationary point, max point, and this is a mean point. So we'll be working with both types of stationary point in this chapter. So let's look at one of the questions. If I make x subject, I get x is equals to 0, which means this curve has a stationary point at x is equals to 0. That is, the curve is like this. The curve is like then the stationary point is here. It is 0, 6. The last number represents that doesn't have a variable represents the y-intercept. Thus, the y-intercept is 6, and the stationary point is at 0. So the stationary point is at 0, 6. So we can say the y coordinate is 6. So y is equals to 6 at stationary point. STATIO. I used y is equals to 4x squared plus 6. I used differentiation to find the gradient, to find an equation for the gradient of this curve. Then I equated that equation to equals to 0 so that I can find the x coordinate of the point where the gradient of the curve is 0. 0. Thus I found, then after finding the x coordinate, I substituted the x coordinate into this equation to find the y intercept. The y coordinate not the y intercept, the y coordinate at which the curve has the stationary point. If I put 0 here, 0 to the power square is actually 6. 0 plus 6, then thus the y coordinate at the stationary point is 6. So is the second part of the question states, determine its nature. Nature means is it a minimum curve or a maximum? So to find its nature, we need to do further differentiation. That is, we need to find d square y by dx. D square y by dx square. So what is d square y by dx square? It is differentiating the equation that we first differentiated. That is, we've initially differentiated 4x square plus 6x to get 8x. Then to get d square y by dx square, we need to differentiate this. We need to differentiate 8x to get d square y by dx square. So d square y by dx square is just the second differentiation. So if we differentiate 8x, we get 8. We get 8. So as this value is positive, we can say the curve is a minimum curve. If this value would have been a negative value, we could have said it's a maximum curve plus V. Therefore, minimum curve. Whenever we end after d square y by dx square, whenever we end up with a positive value, we can say it's a minimum curve. If we end up with a negative value, we would say it's a maximum stationary point. Minimum point. And in many cases, we don't end up with a magnitude. In many cases, after doing d square y by dx square, we end up with a formula like 8x square or 5x square. In that case, we need to substitute the x coordinate that we got initially. Like here, the x coordinate we got was 0. So if we ended up with an equation like d square y by dx square is equals to 10x, then we need to substitute the x coordinate of the stationary point. Like if we know the x coordinate of the stationary point was x is equals to minus 6, then we need to substitute this minus 6 into this 10x to find the d square y by dx square. Then if we substitute minus 6, we get minus 60. So in this case, minus 60 is a negative. Thus, we could say that this curve, this d square y by dx square of is a maximum point, as we ended up with a minus 60. This has nothing to do with this. This part has nothing to do with the actual math that I showed now. This is a different scenario that I'm giving an example where we might end up with a formula with a equation with an equation after d square y by d square. That in that case, we would just have to substitute the x coordinate of the stationary point. So question 3 says that find the y coordinate of the stationary point of the curve and its nature. So as I said earlier, at the stationary point, every curve at its stationary point has zero gradient, and we use differentiation to find the gradient of a particular point at of at a particular point of a particular curve. So first, let's differentiate it. Let's do dy by dx. We bring the power in front. 4 times 2 is 8, and subtract 1 from the power, that is 4x. Plus, if we differentiate 4x to the power 1, as 2 minus 1 is 1, and if we differentiate 6, it becomes 0 plus 0. So dy by dx is 8x. Now, as this 8x represents the gradient of the curve at the x coordinate, thus I can write 8x is equals to 0 to find the x coordinate. 8x is equals to 0 to find the x coordinate of the stationary point. This was all about stationary point. Let's move on to the next topic about tangent normal. So the next topic is tangent normal. This is not a complicated topic. This is a very easy topic actually. So let's look at a question. First question, the question 5 actually says, find the equation of the normal to the curve y is equals to x cubed plus x squared minus 4x plus 6 at point 1, 4. I want to add something to this question, that is also find the equation. We write this as the short form of equation of the tangent at these points. Okay, now let's get started. So we are given with let's first write the equation y is equals to x cubed plus x squared minus 4x. So we all know that both the normal and tangent are straight lines. So we need to find the equation of these two. We need to use the straight line equation, that is y minus y1 is equals to m, that is gradient, x minus x1. So as we know the y and the x coordinate, thus we only need to find the gradient of the tangent as well as the normal. So first let's find the gradient of the tangent. As I said previously, we use differentiation to find the gradient of the tangent at a particular point. So first let's differentiate this equation, that is dy by dx to the power in front, dx to the power square, 3 minus 1 square 2 plus 2x minus 4. So this is the differentiation of this equation. So if I substitute the x coordinate, that is 1, into this equation, I get this gradient of the tangent of the curve at that particular point. So let's do it. At x is equals to 1, dy by dx is equals to 3, 1 whole square plus 2, 1 2, 1 minus 4. So it becomes 3 plus 2, so it becomes 1. So the gradient of tangent is 1. Let's check it further. So the gradient of the tangent is 1. So let's now find the equation of the tangent, that is y minus y1. What was the y coordinate? The y coordinate was 4. So y minus 4. First, let's label it as the equation of tangent. Equation of tangent. Sorry, let's not write equals to. Let's give an arrow. Y minus the y coordinate was 4 and the gradient is 1, 1, x minus x coordinate is 1. So the equation of the tangent becomes x minus plus 4. So this is the equation of tangent. Now we are told to find, now previously we are told to find the equation of the normal. We all know that the tangent and the normal are perpendicular to each other. Thus, we can find the gradient of the normal, but just by using the formula f of normal multiplied by f of tangent equals minus 1. So if the gradient of tangent is 1 and then gradient of normal is m, the result must be minus 1. Then we just have to make m subject to get the gradient of the normal. So the gradient of the normal becomes minus 1. Actually, in case of two lines that are perpendicular to each other, the gradient of the perpendicular line is the negative reciprocal of the other. Like if I say this line has a gradient, these two lines are perpendicular to each other, and the vertical line has a gradient of 5. The perpendicular line to this line should have a gradient of minus 1 by 5, the negative reciprocal. Whenever two lines are perpendicular each other, the gradients are negative reciprocals of each other. So the gradient of normal is minus 1. Okay. Now let's find the equation of the normal. Equation of the normal. Y for the y minus 4 minus 1 x minus x1 if the coordinate was 1. So the gradient of normal formula for the equation of normal becomes minus x plus 4. Sorry, in this case, the equation of the tangent is not y is equals to x plus 4. It is actually something else. I made a calculation mistake. Sorry. It is actually plus 3, not minus 4. It's plus 3 as it is a minus 1 plus. So it's a plus 3. And in this case, it's a plus 5, not plus 4. I made a calculation mistake. Sorry. In this case, it's a plus 5. So the equation of the normal is y is equals to minus x plus 5, and the equation of the tangent is y is equals to x plus 3. So this is how this problems regarding tangent normals are done. It's not very complicated. It's actually very easy. Now let's move on to the next topic, that is rate of change and approximation. So our next topic is rate of change and approximation. Rate of change and approximation are actually two different topics. So let's look at rate of change, then we'll go with approximation. So what is rate of change? In rate of change, we actually find change in something by change in time, which is represented by dy by dt. In differentiation, we do dy by dx. But in this case, in case of rate of change, we do dy by dt. Let's see one question. So question 10 says that in this question, all lengths are in centimeters. The volume of a cone of height h and base radius r is given by v is equals to 1 by 3 pi r h. So we know that the volume of a cone that has a circular base is formula of the volume of a cone that has circular base is v is equals to 1 by 3 pi r square h. Okay. It is known that sine pi by 12 is equals to root 6 minus root 2 by 4. These are just some trigonometrical identities that we might need while solving math. A water cup, these are all just given informations. A water cup is this a water cup in the a water cup is in the shape of a cone with its axis vertical. The diagram shows the cup and its cross section. The vertical angle of the cone is pi by 6 radians. The depth of water in the cup is h. So this angle is pi by 6 radians. It has a circular, this is just a cross sectional view of this thing. It has a circular base or top head. It has a circular roof and the bottom is pointed like this. So it's a cone. It's a cross sectional view of a cone. Okay, let's continue. The surface of the water is a circle of radius r. The radius of the circle at the roof is r. Find an expression for r in terms of h and show that the volume of water in the cup is given by v is equals to, okay. So first let's solve a, then we'll go on with the actual rate of change question that is in part b. So first let's solve question a, part a. Let's first draw the diagram. It says there is a triangle. This angle is pi by 6 and this, the entire thing is 2r diameter. As the roof is circular, then and the radius is r, then the diameter should be 2r. Okay, now if I draw half of this triangle, that is like this, it forms a right angular triangle. Sorry. Yes, it forms a right angle triangle with 90-degree at this edge. Then this length becomes r, as we are taking half of the triangle. The half of 2r is r, and the angle pi by 12, that is half of pi by 6. Then now we can just use trigonometric formulas to find. One more thing is that this height is h. As this height should also be h. This length should also be h and this length r. Now we can just use the trigonometric formulas to find, to express r in terms of h. So let's see, what do we know, the opposite side and the adjacent side. Thus we need to use tan. Here I can say tan pi by 12 is opposite by adjacent op by adj. By saying adj I mean adjacent, and opp I mean opposite. So this opposite is r and the adjacent is h. Now I can easily find r in terms of h. So r becomes, r is equals to h tan pi by 12. Now let's see what we have to find next. We found r in terms of h. Now we have to find the volume of the water body in terms of h only. So as we know, the formula of the volume of a cone is v is equals to 1 by 3 pi r square h. Now let's substitute the expression for r that we got in this formula. Let's see what happens. V is equals to 1 by 3 pi r square h. This is the volume of the cone, and we are told to find V is equals to pi 7 minus 4 by root 3 h cube by 3. Okay, so we are told to find this pi 7 minus 4 root 3 h cube by 3. Now let's substitute this r into this equation. If we substitute r, it becomes 1 by 3 pi r. Now there is no r, pi h, and instead of r I put h and pi by 12 whole square. As there was a square above r, so I have to put a whole square. Now after that, if I take the h out of the bracket, then it becomes 1 by 3 pi h cube. As there is a square on this edge and no square on the one, and a power of 1 on this edge, the power gets added up to become 3. So the power of h is 3. Now we are left with 10 pi by 12 whole square. So earlier, not whole cube, it's a whole square. So earlier in the question, we were given with some trigonometrical identities. Like here, we are told 10 pi by 12 is 2 minus root 3. So if 10 pi by 12 is equal to 2 minus root 3, then I can substitute this 2 minus root 3 into this 10 pi by 12. Let's see what happens. Then v becomes 1 by 3 pi h cube 2 minus root 3 whole square, as there is a whole square above 10 pi by 12. Okay, now let's simplify it. uh, First let's expand the brackets. Pi h cube, if we use the a plus b whole square formula, then it becomes a square, that is 4, minus a minus b whole square, not a plus b, sorry, a square minus 2ab, 2 times 2 4 4 root 3 plus b square. B square is root 3 whole square is just 3. So if you don't know the a minus b whole square formula, then let me show you it. If there is something like a minus b whole square, we write a square plus minus 2ab plus b square. That's exactly what I did to convert this into this. Okay, now let's continue. Then it becomes, sorry, I wrote an half here. It's actually 1 by 3. Okay, now let's continue. 1 by 3 pi h cube 7, 4 plus 3, 7 minus. I think we are done with this. We are done with the part A, as this equation is actually this equation. I just need to rearrange it. Like, I can divide the entire thing with 3. Like, I can write it in this manner. Pi, sorry, pi 7 minus 4 root 3. I can write h cube on this side and 3 in the bottom. Thus, we did shown. We have to write a shown because we are told to show that the volume of the cone was this. So we are able to show it. We ended up in that equation. So part A done. Now let's go on with part B. In part B, we are asked B. Water is poured into the cup at a rate of 30 centimeter cube per second. So the rate of change in volume, the volume, that is dV by dt. 30 centimeter cube is the volume of water that is inputted or poured inside the container. So it is change in volume by change in T. As I said, the rate of change means dV by dt. So rate is dV by dt is equals RT. Okay, now find correct to two decimal places the rate at which the depth of the water is increasing when h is equals to 5. Okay, so first, what do we need to do? We need to find dV by dH. Delta V dV by dH. That is, we just need to differentiate V with respect to h. Let's do it. If this is the equation of V, the dV by dH should be, we can see that this entire thing, this, sorry, so, so if we see this entire thing that I'm circling is just a constant with h cube as the variable. Thus, we need to use the simple formula of differentiation, this first formula. We just need to use this first formula, that we bring the power in front and subtract 1 from the power. So let's do it. This is a constant. We bring 3 in front. Let's remove the circle. It's getting confusing. So let's bring 3 in front. If we bring 3 in front, the 3 and 3 gets cancelled out. 3 pi 7 minus 4 root 3. And we subtract 1 from the power. That is 3 minus, sorry, 3h. 3 minus 2, 3 minus 1, it becomes 2. And we have a 3 in the bottom. So this 3 and this 3 gets cancelled out. So we end up with a dV by dH, that is pi 7 minus 4 3 by h squared. But there is nothing in the denominator, as we cancel out the 3. Now the interesting thing comes for rate of change. This is something new that we didn't learn before. So we are told to find the the rate at which depth of water is in the depth of water, that is the height h, the dh by dt, rate at which the depth of water is increasing. So we are told to find dh by dt. Question. So we are told to find dh by dt and we were given with dv by dt. And we know we just found out dv by dh. Now let's see how it's done. So as we are told to find dh by dt, rate of change of depth, the change in height per unit time. So now I'm going to use something called mathematical magic. That is, I write dh multiplied by dt. And if then we put the same numerator, same thing as the numerator and the denominator so that it can get cancelled out. We don't change anything. So we know dv by dt. Yes, as we know dv by dt, so let's write dv. And we also know dv by dh. So let's write dv. I wrote dv in the denominator as well as the numerator, thus it can get cancelled out. So it doesn't change. It's the same as dh by dt. It's the same. This thing is the right hand side of the equation is the same as the left hand side of the equation. Now we know dv by dt. So dh by dt becomes, we know dv by dt, that is 30 centimeters per second. Where is that? We know dv by dt, that is 30 centimeters per second. We just don't know dh by dt. And we are told to find the dh by dt at h is equals to 5. So we know the h is 5. Okay. So as dv by dt is 30, let's write 30. Then we multiply dh by dv. So you might ask, we know dv by dh, not dh by dv. So as dh by dv is just the reciprocal of dv by dh, so we can just flip this equation. We can just flip this equation to get dh by dv. So if this equation is dv by dh, the dh by dv, we just have to reciprocal this, then that it becomes 1 by pi 7 minus 4 root 3 h square. Now we are told to find the rate of change of height at h is equals to 5. So we need to find the dh by dv at h is equals to 5. So let's put it in the formula. Pi, sorry, pi 7 minus 4 root 3, and instead of h I put 5 also. Now if we put the entire thing into the calculator, we will find dh by dt. This rate of change is a bit more complicated, so you might want to rewatch this part of this video to remove all your confusions regarding this rate of change. So if we put this thing into the calculator, we get 30 by pi 7 minus 4 root 3 times 5 square. So we get 5.32, which is actually the answer to our question. 5.32, and the unit is cent. Sorry, and the unit, as we know, as we were given with the dv by dt as cm cube per second. So the unit to dh by dt should be centimeter, as the unit of h is centimeter per second. S minus 5.32 centimeters per second is dh by dt. So you might want to rewatch this video because this was a bit complicated chapter, I know. So if you are confused with something, just rewatch this part of the video. Then your confusions will be clear now. Now let's move on to the last, no, not the last, the second part of rate of change and approximation, that is approximation. Let's, so in approximation is not a difficult topic. It's actually very easy. The main thing that we have in approximation we do is whenever we have a change in something. For example, we have a change in x coordinate, that is change in x equal to, let's say the change in x is 5 units. 5 units. Then we are told to find the change in y, approximate change in y. If the change in x is 5 units, what will be the change in y? and we'll be given with an equation. So we need to use differentiation to find the change in y if we are given with the change in x. Let's see one example of approximation. Let's see one example of approximation. So this question says that the variables x and y are such that y is equals to ln 3x minus 1 for x greater than 1 by 3. So in part A, we are told to find the derivative of y dy by dt. Let's first do it. Then in part B, we will see what rate of approximate change is, what is approximation actually is. So let's do A for A. Y is equals to ln 3x minus 1. So if we look at the formula list, we differentiate equations that contains ln using this formula, the formula number 5. I have provided the formula list in the first video where I taught differentiation. You can check there, look there. Ln ax plus b, we inverse the ax plus b, we inverse the ax plus b, that is we write 1 by the whatever it's in the bracket, whatever there is in the bracket, then we different multiply the entire thing with the differentiate derivative of whatever it is inside the bracket. Inside here in this case, inside the bracket there was ax plus b, we put ax plus b as a denominator, then we put multiply the differentiation of ax plus b and put that differentiation as the numerator, that is d by dx of ax plus b divided by ax plus b. So let's do it. So first I do dy by dx, right? Dy by dx. First let me put 3, the whatever it is in the whatever there is in the bracket as the denominator, 3x minus 1. Then we differentiate 3x minus 1. What is the 3x? What is the differentiation of 3x minus 1? Is 3. So we put 3 as the numerator. We multiply the entire thing with the differentiation of 3x minus 1, that is 3. So the difference dy by dx becomes 3 or 3 by 3x minus 1. Okay. Now that we know the differentiation of 3 of y is equal y, let's move on to part B. In part B, we are asked to find the approximate change in x when y increases from ln 1.2 to ln 1.2 plus 0.125. Okay. Whenever we are whenever we are told y increases from this to that, we first need to find the initial value of x. Like here, the initial value of y was ln 1. What was the initial value of x? We need to find by putting ln 1 by 2, 1.2 in y and equating this equation. Let's do it. To find the initial value of x, it's ln 1.2 b. In y, we substitute ln 1 by 2 into y, then we equate it to ln 3x ax minus 1. If we cut the ln from both the sides, we can say 1.2 is equals to 3x minus 1. So now we can make x subject to find what is x. So x becomes 1.2 plus 1 by 3. So x becomes 11 by 5. 15, not 5, 15 actually. 11 by 15. So now when we are told y increases from this to that, and we are also asked to find the change in x. So if you see, the initial value of y was ln 1.2 and the final value of y is ln 1.2 plus 0.125. Let's write it. Sorry. Initial y and final y. Initial y was ln 1.2 and the final y is ln 1.2 plus what? Plus 0.125. 0.125. So we can, from this information, we can easily say that the change in y is actually 0.125, because if we subtract final y minus initial y, we eventually get 0.125. So change in y, that is approximate change in y, is 0.125. Sorry, I wrote 3 instead. Now we are told to find the approximate change, approximate change in x if y increases by 0.125. So we know the initial x. What is the initial x? The initial x is 11 by 15. When y was ln 1.2, x was 11.15. This is initial x. So what is final x? Initial x. So in terms of approximation, we use this symbol. Approximate change in y is approximate y by approximation change in x. This symbol represents approximate change in y, and this symbol represents approximate change in x. Approximate change. This symbol, we represent approximate change by this symbol. Change. Okay. So in case of approximation, we say this is del. We represent this as del. Del y by del x is equals to dy by dx. In case of approximation, we say del dx, that is change in y by change in x, is equals to dy by dx. We learned that earlier, that dy by dx basically means change in y by change in x. So if the change in y, say change in y is 0.125, okay, 0.125, and change in x, we don't know, we need to find change in x. So let's try. So del x. Now, in case of dy by dx, we know equation of dy by dx. That is, we found earlier in part A. This is the equation of dy by dx, but we don't know the numerical value of dy by dx. Thus, we need to substitute the initial x in this equation. The initial x, not the final x. Here the initial x was 11 by 15. I found the initial x so that I can substitute it into the dy by dx to find the approximate change in x. So in this case, I need to substitute 11 by 15 into this dy by dx. Let's do it. The dy by dx was 3. Inside, in the denominator, we had 3. Instead of x, I write 11 by 15. And then after 3, what was there? 3, 11 by 15 minus 1. Okay. So this is the dy by dx when we substitute the initial x. Now you just have to make the del x to find the approximate change in x. Let's do it. If I make del x subject, what does it become? What does the equation look like? It becomes 0.125 multiplied by 3, 11 by 15 minus 1. So there is a bracket, okay? Now we divide the entire thing with 3. If we put this into the calculator, we find the approximate change in x. Let's see what it is. Minus 1 by 3. So we get 1 by 20, that is 0.05. Okay, so that we can say the approximate change in x is 0.05 when the approximate change in y was 0.125. So one thing that is very important in always when we have to find the numerical value of the differentiation, we always use the initial value of x, not the final. So to find the initial value of x, we substitute the initial value of y into the equation that we were given with. Here y is equals to ln 3x minus 1. We substitute ln 1.2 in y to find the initial x. In many cases, we will be given with the initial value of x. Like x increases from this to that, and that in that case, as we are given with the initial value of x, we put the initial value of x into the differentiated expression or equation. Then we use that equation to find the approximate change in y. When we are given with the approximate change in x, we are told to find the approximate change in y. So then we'll use del y by the known del x equals to dy by dx that we find by substituting the initial value of x. So this is also a bit complicated topic. You might want to rewatch this part of the segment as well to clear all of your confusions. So this is it. Now let's move on to the final part of differentiation, that is mensuration. So mensuration is very similar to minimum the stationary point that we learned earlier. Here actually we are given with an equation and we are told to find the minimum point or the minimum value or the maximum value. In many cases we have to find our own equation. We are not always given with the equation. So let's see one example. So this question says that in this question all lengths are in centimeters. A closed cylinder has a base height h and volume v. It is given that the total surface area of the cylinder is 600 pi and volume and that v, r and h can vary. V is the volume, r is the radius and h is the height of the cylinder. A, show that v is equals to 300 pi r minus pi r cube. So in this case we are not provided with the equation, we are told to show the equation. So let's first show it. 2a, we know the volume of the cylinder is calculated by the formula V is equals to pi r square h. Yes, the volume of the cylinder is calculated by the formula pi r square h, and the surface area of the cylinder is calculated by the formula 2 pi r square plus 2 pi r h. This is the formula of the surface area of the cylinder, and this is the formula of the surface volume of the cylinder. So we are given with the we are, if you notice in the formula of volume that we have to show, there is nothing called h. The height is not there. Thus, it means we need to substitute an equation, an expression of h into the formula of volume so that h cancels, it gets cancelled out. By this, I mean we need to find an equation of h in terms of r so that after that we substitute that equation into this formula, we just have r as the only variable, as we are finding an equation of h in terms of r. So let's do it. Let's find an equation of h in terms of r. So we are told the surface area of the cylinder is 600 pi. So let's write 600 pi, which is equals to 2 pi r square plus 2 pi r h. So let's make h subject in this equation. 600 pi. If we take 2 pi r square to the other side, it becomes minus 2 pi r square. And now E equals to 2 pi r h. Now I can take just the 2 pi r to the other side, then it will become 600 pi minus 2 pi r square by 2 pi r, which is equals to h. Now that I've gotten the expression of h in terms of r, let's substitute this expression into the formula of volume, that is pi r square h. Okay. So we are told to find the formula, that is v is equals to 300 pi r minus pi r cube. 300 pi r minus pi r cube. So we are told to show this equation. Now let's see, can we show that equation or not? Let's substitute this h into the formula of the volume, that's pi r square h. Pi r square, instead of h I write 600 pi minus 2 pi r square by 2 pi r. Okay. Now let's simplify this equation to take this equation to this. Okay, let's continue. I can cancel the pi r from the numerator and the denominator. I can cancel the pi's as well as 1r. Then the equation becomes b is equals to r 600 pi minus 2 pi r square by 2. I've cancelled out the pi r from the numerator and the denominator. Okay, as I've divided both to be 1. Okay, now let's continue. So if we separate the 600 pi and the 2 pi r square, the equation becomes 600 pi r by 2 minus 2 pi r cube, because the r is getting multiplied with the r square, then it will become cube by 2. The 2 gets cancelled out, and 600 by 2 is 300. Then the final equation becomes 300 pi r minus pi r cube. So let's see if we find out. Yes, we are told to equation, and we succeeded in show this equation. So let's write show. We were asked to show that the volume of the cylinder would, would obey this equation. So we have shown. So we are done with part A. Let's go in part B. Now let's look at part B. In part B, we are asked find the stationary value of V and determine its nature. Okay. As we learned in the stationary point segment, the stationary point of a curve happens whenever there is a zero gradient. The stationary value means the curve has a zero gradient at that point. So how do we find it? We differentiate the curve, equate that differentiation equation 2 equals to 0. Then we find the r value. To find the value of r at which the volume has a stationary value. So in this case, first we need to find the value of r at which the volume has a stationary value. Then we need to substitute that value of r into the volume equation that we have here to get the stationary value of v. Let's get started. Afterwards, we need to determine its nature. We'll do it afterwards. First, let's do the first part. So let's see. So we have the equation of v here. In part B, first we need to find dv by dr. That is a differentiation of v with respect to r. So if we differentiate v with respect to r, what do we get? We get 300 pi minus, we bring 3 in front, 3 pi r square. Okay. So this is the derivative of volume of v, of equation v. Now we need to equate this equation to 0 to find at which value of r the v has a stationary value, that is zero gradient. We use difference. This differentiation represents the gradient. So at which value do we have zero gradient? Which value of r do we have zero gradient? So let's make r subject. Then the equation would look like 300 pi equals to 3 pi r square. We take 3 pi to the other side, then r square equals to 300 pi by 3 pi. Now we just cancel out stuffs. We end up with r square is equals to 100. So if we do 100 square, if we take square to the other side, it gets root 100, it becomes 200. So r becomes 10 centimeter. As all the lengths are in centimeters, so r is 10 centimeter. So at 10, at r is equals to 10, the v has a stationary point, that is v. This equation v has a gradient 0, has zero gradient at value of r equals to 10. So let's check it once. So let's not check it. Let's find the stationary value of v when r is equals to 10. As we know, v has a stationary value at r is equals to 10. So now we just have to substitute the value 10 instead of r to find the stationary value of r. So let's do it. So v is equals to 300 pi r minus pi r cube. So instead of r, we put 10, 300 pi 10 minus pi 10 cube. Sorry, I wrote 110. I should have written 10. Did I copy the equation right? Yes, I did. 3 pi r square. Pi r cube. Okay. So if we put this into the calculator, we get the stationary value of v. Let's check what it is. Minus pi 10. So we get 2000 pi. So this 2000 pi is the stationary value of v. So which means whenever we differentiate at r is equals to 10, the curve v has a stationary value and it has a magnitude of 2000 pi. 2000 pi, sorry, I wrote a 6 instead of 0. It has a magnitude of 2000 pi. Thus, we can say the stationary value of v is 2000 pi centimeter square cube. Volume is measured in cubes, centimeter cubes. So, If you think you need to watch this part of the segment again, you may, because this part is also a little bit confusing, but it's not that difficult. If you watch it again, you won't have any confusions. So now let's go on with the second part of part B. In the second part, we are asked to determine its nature. In the stationary point part, we learned that a stationary graph has there are two types of stationary points. One is maximum, one is minimum. To find the nature, what do? We differentiate it again. Differentiate the differentiated equation again. That is, we do d square v by d. We do this. How do we do this? We just differentiate this thing, this one. We just differentiate this equation. We differentiate further. Again, we differentiate dv by dr. So dv by dr has an equation of 300 pi minus 3 pi r square. We need to differentiate this equation to get dv by dr square. First, let's write what is dv by dr instead of differentiating it first. So dv by dr is 300 pi minus 3 pi r square. So this is dv by dr, and now we need to differentiate it to find d square v by d r square. Square, not actually square. So if we differentiate it, we get, if we bring 2 in front, we get a minus 6, 3 times minus 2. There is a minus symbol, thus we keep the minus symbol and multiply 3 times 2, we get minus 6. Differentiation of 300 pi is 0 minus 6 and pi r. So the d square v by dr square is 6 minus 6 pi r. Now we just substitute the r value that was 10 centimeter at the r value at which the stationary value occurs to get the d square v by dr square. So let's see, at r is equals to 10, we get 6 minus 6 pi 10. It is minus 60 pi. So obviously this value has a negative magnitude, it's a negative magnitude. Yes, it's a negative magnitude, which means it's a maximum curve. It is a maximum point, like this. In the stationary part segment, I told whenever we end up with a negative value, that is a maximum point, and whenever we end up with a positive value, that is a minimum point. Here, after substituting the value of r at which the stationary point occurs, we get a negative minus 60 pi. Minus 60 pi, that's a negative value. Thus, we would say therefore, it is a maximum value. Maximum stationary value. ST, by saying ST, I mean stationary value. Your exams, you cannot write ST. I'm just writing ST to explain you. In your exams, you have to write stationary, the full form. So this is it for mensuration. It was a little bit complicated, I say. Differentiation is not that easy. Thus, you might have to watch this video again, not the entire video, but a few parts of this video. You might have to watch it again to clear all of your concepts. But this will be worth it. If you have any confusions, watch this video, not the entire video, but wherever you have that confusion, watch that part again. Your confusions will be clear. I hope so. So this was the last topic of differentiation. So let's review whatever we learned. Let's see what topics we learned in this video. So in this video, we learned these 5 topics.
If you feel like you could benefit from more practice, consider enrolling in our affordable courses available at Cheshta Academy. Our courses cover each GCE O-level additional mathematics topic thoroughly with a brief test following each chapter. Click the link provided in the description box to access the registration form. For more details, reach out to us via our Facebook page or email us at Cheshta Academy, cheshta.academy86@gmail.com, given in the description box. So till then, stay safe. Thanks for your time. Assalamu alaikum. In the next video, we will be looking through problems of integration. Till then, bye bye.